I want to talk about the concept of optimization. Optimization, you probably have heard it before. In mathematics, optimization is the process of finding certain values, certain quantities, such that some equation, such that a given equation is maximized or minimized. So maximized or minimized. So let's take an example after I spell minimized. Let's say we are picking two numbers. We wish to pick two numbers such that when you add them up, you get sum of 6. So the two numbers can be what? Two numbers can be 1 and 5. The numbers can be 2 and 4. The numbers can be 3 and 3. The numbers can be 2.5 and 3.5. This goes on. There's infinitely many pairs of numbers you can choose such that their sum is equal to 6. But that's not the end of it. We wish to maximize the product of the two numbers. So for 1 and 5, what's the product? For 1 and 5, 1 times 5 is 5, so the product is 5. For 2 and 4, the product is 8. 3 and 3, the product is 9. For 2.5 and 3.5, the product is going to be something. And we want to find the pair of numbers such that the product is going to be the largest. Actually, since we're 2.5 and 3.5, let's multiply them out, see what we get. Might as well. Let's not mess up this multiplication. 7.5. So we have what? 8.75. So we have 8.75 for 2.5 and 3.5. So from the list that we have, it seems like 3 and 3 gives us the largest product. But there's infinitely many values that we can test out. So this certainly doesn't mean 3 and 3 is necessarily the answer to this question. We somehow have to prove it mathematically. So how can we verify that 3 and 3 or some other pair of numbers is going to have a sum of 6, but it's also going to have the maximum product? We can start off by letting the numbers be x and y. It can be a and b, it can be c and d, or any two numbers. And we know x plus y has to be 6. But that's not it. What do we want to maximize? We wish to maximize x times y. We wish to maximize x times y. So let's call this function. This can be a function of x and y. But the thing is, we can simplify this into a function of one variable using the constraint that x plus y is 6. This is the constraint. And this is the primary equation, primary function that we wish to maximize. So we can use this constraint to reduce the primary equation into a function of one variable, which we can then find the maximum or minimum of. So this constraint is telling us that y is equal to 6 minus x, and we can plug this in, we can substitute this back into our function to get x times y, or x times 6 minus x. Now realize this thing does not have y. So we know how to maximize this. So this thing is 6x minus x squared. How do you maximize it? You find the derivative of f. So you get 6 minus 2x, and you want to set this equal to 0, and that gets us x of 3. So you know x equals to 3 is a critical number or critical value of this function. And how can we verify that this is maximum or minimum? Since we have 6 minus 2x, which is easy to differentiate, let's use second derivative test. F double prime of x is negative 2, which is less than 0 for all x. So we know at x equals to 3, the f is concave downward. So we know the function has to go like this. Concave downward looks like this. And we know the f prime is 0. So at x equals to 3, we have relative maximum. So we have figured out when we let x be 3, we have the maximum product. But what is y? What is the corresponding y? Well, y is 6 minus x. X is 3, so y is going to be 3. So the pair of numbers that's going to give us maximum product such that their sum is 6 is 3 and 3.